Welcome to the video for SmartTut 5. The first exercise we're looking at is under section 5.5 and it's number 7. It says find the average value of the function on the given interval. So we have the function h of x equals cos to the 4x sin x between 0 and pi. So very straightforward. We are just going to use our formula for getting our average value. So h average is going to be 1 over the end of the interval minus the beginning, and then we have our integral from 0 to pi of h of x, so it's cos to the 4x sin x dx. So how do we do an integral like this again? Well, we can use a simple u substitution. We can just set u equal to cos of x, and then we have the derivative of cos of x, which is sin of x, in there. So I'm going to say let u be equal to cos x, then du equals negative sin x dx. So du over minus sin x equals dx. And I'm going to change my bounds as well. So when x is 0, then we have cos of 0, which is 1. When x is pi, then we have cos of pi, which is minus 1. All right. So now I'm going to substitute this back into my integral. So what I have is 1 over pi. Then I have the integral from 1 to minus 1. Then I have u to the 4 sin x negative du over sin x. Right, so those two sins cancel. Then I have a minus here, but what I can do is I can just change my bounds from minus 1 to 1 and then just remove the minus, right? Then also I can write this as 1 over pi times the integral from 0 to 1. So I change my bounds from minus 1 to 1 to 0 to 1, and then I'm just going to add a 2 in front of my integral. Right? I can do that since my function u to the 4 that I'm integrating is symmetric. So then it's u to the 4 du, which is, so the integral is going to be 2 over pi, and then we have u to the 5 over 5, and it's between 0 and 1. So if I substitute in my bounds, my final answer is 2 over 5 pi. Next we have number 13. It says if f is continuous and the integral from 1 to 3 of f of x dx is 8, show that f takes on the value 4 at least once in the closed interval from 1 to 3. Well, since f is continuous, we can say by the mean value theorem, so let's just write that down. F is continuous on the interval from 1 to 3. So by the mean value theorem for integrals, there exists a number c in the interval from 1 to 3 such that the integral from 1 to 3 of f of x dx equals f of c multiplied by the closing bound minus the starting bound. And they tell us that this integral equals 8. So this means that 8 equals f of c multiplied by 2 And that means that f of c equals 4. So there is such a number C. Next, we are looking at the exercises under section 6.5, and we are looking at number 3. It says, bacteria culture initially contains 100 cells and grows at a rate proportional to its size. After an hour, the population has increased to 420. Find an expression for the number of bacteria after T hours. Right, so firstly, we know since the bacteria grows at a rate proportional to its size, that means the differential equation has the form dp dt equals k multiplied by p, where k is some constant. And in section 6.5, we said that the only solution of a differential equation of this form looks like the following. So we know that a solution is then P of t equals P0 e to the kt. So what else do they tell us? They say after an hour, the population has increased to 420, right? And they say initially it contains 100 cells, right? So that means P0 is 100. So I can write here, I have 100 e to the kt. Now I want to solve for k. Now I'm going to use my other piece of information that after an hour the population has increased to 420. So I'm going to say after an hour I have 420 equals 100 e to the k multiplied by 1. So all I did was I substituted that information in here. Right. So this means that I have e to the k equals 420 over 100. And that means that k equals ln of 4.2. Right. Now, the next question says, find the number of bacteria after 3 hours. So that's very straightforward. We are simply going to substitute 3 hours into our equation that we have. So our equation looks like this at the moment. 100 e to the ln of 4.2 multiplied by t. I'm just going to write my t in front there, which of course I can write as 100 e ln to the 4.2 to the power of t, which is then just 100, and then I have multiplied by 4.2 to the t. Right, so after 3 hours I have P3 equals 100 and then 4.2 cubed. Right, and the value you get there is approximately 7409 bacteria. Then they say in the next question, find the growth after 3 hours. Right, so in other words, we said in the beginning that since the rate is proportional to its size, its growth rate, dp dt equals k multiplied by p. So dp dt equals k multiplied by p. That means the derivative of p, which is just this, after 3 hours has to be k multiplied by the population. at time 3 and the population at time 3 is going to be, so firstly I'm going to fill in ln of 4.2 because that's k, and then P3 is going to be 100, and then we have 4.2 cubed, right? So they asked for the growth rate, the rate of growth after 3 hours. This is the rate of growth after 3 hours. We've worked it out here, and if you work out that value, approximately 10,632 bacteria per hour. And the final question is, when will the population reach 10,000? So all we're going to do then is we are going to say, so we're going to use our formula. P of t equals 100 times 4.2 to the t, and then we are going to set 10,000 equal to that. So 10,000 equals 100 4.2 to the t, which means that we have 100 equals 4.2 to the t, which means that I have ln of 100 equals ln of 4.2 to the t, which I can write as t ln of 4.2, which means that t is going to be ln of 100 divided by ln of 4.2, and that gives us approximately 3.2 hours. This is the end of the procedure exercises.